Okay, this is day 25. This is going to be part two. Let me write that down there. Day 25, part two. So, given below is a relationship that exists when a composite function is formed using a function and its inverse. Use the chain rule to differentiate both sides of the equation and find the formula for the derivative of f inverse of x. All right, so what the heck are we doing here? Well, what I need to do, chain rule. Let's first do the derivative of the right side. That's going to be nice and easy. So again, differentiate both sides of the equation below. Derivative of x is 1. Now, chain rule, outside, inside. So take the derivative of the outside. So that's going to be f prime. Now, leave the inside the same. That's going to be f inverse of x. And now, so again, the derivative, if it was power rule, we'd be using the power rule. If it was product rule, all that stuff, we're just taking the derivative, whatever that outside function is. The derivative of the inside stays the same. And then what do? We then take the derivative. I gotta move this over a little bit. Both these over. I'm gonna have to erase that. Hold on. All right, now I left myself enough room. Now I need to take the derivative of what was on the inside. So that's f inverse of x, and I want to take the derivative of that. Okay. And now what do I want to do? I want to I want to find what the derivative of this is. So that's right here. So I need to get that by itself. How do I get that by itself? I'm going to divide both sides by what was left over, f prime of f inverse of x. So I'm going to be left with the derivative of the inverse right there, and that's going to be equal to 1 all over f prime of inverse of x. Okay? So this now lets us know what the derivative of the inverse is. All right, so let's come down here and figure out what we can use this for. So, what did they tell us? Well, they told us, again, suppose that f of x equals 3x plus 2. This is some information. Hey, the derivative of f at negative 2 is equal to 3. And what is this value? All right, so we're trying to find derivative of the inverse. So let's start setting up what we have up above. So, hey, I know the derivative, oh, sorry, let's do that again. Inverse, instead of at x, we're looking at 4, and I'm taking the derivative of that. That's going to be equal to 1 all over derivative of f of the inverse at 4. Um, so all I've done is copied this up above here. That's supposed to be inverse, sorry. Instead of x, I replace the x, I put in 4. All right, well, I'm kind of stuck here. So um, let's go through and let's see when this original function is equal to 4, what we get. So 3x plus 2 is our original function. Hey, when is this equal to 4? So I subtract 2 from each side. I get it equal to negative 6. So x equals negative 2. So in my original function, I know that when x is negative 2, the value of the function is negative 4. Okay, that's kind of helpful, but nowhere on here do I have that. But where it's really helpful is the inverse. I can then switch the x and the y. Well, this was the y, so now that's my x, and then therefore what was my x is now my y. So where's that located? That's located right here, okay? So now, again, we're trying to find the derivative of the inverse. Well, that's equal to 1 all over the derivative of f times, and what did we just say that value was? This inverse of f at 4 is going to be equal to negative 2. Okay, and now what's that equal to? Well, what's the derivative of f when x is negative 2? They had to give us that, and that equals 3. So I just found the the derivative of the inverse to be 1/3. Okay, a lot going on there, but we're slowly putting together everything we've done this year with, again, chain rule and all that stuff, but now we're starting to add in inverses. Okay, and again, this was helpful. Hey, when is this function equal to -4? When x equals -2. Therefore, the inverse, when x is -4, that must be -2. And that helped us solve this. All right, so now we're given a table of values. We have f, g, f prime, g prime. Use the tables to find the indicated values. So we got a lot we got to look at here. So we're going to use the same thing we just did. So it says find the value of the derivative of the inverse, which is what this whole section's about. So here's my inverse when x is 3. All right, so what do I know that's equal to? That's going to be equal to 1 all over derivative of f of, and let me write that, hold on, of inverse f at 3. Okay, now I got to use my data table. So now we're only working with the right side. That's what we're trying to find. So now let's come over here, and I'm going to start with, hey, what's the inverse f of 3? Here's inverse. I want to find inverse f of 3. So let's figure that out. So they don't have the inverse, but I know, hey, f is when the y value is 3 of the original function, when x is 1, therefore this value is going to be 1. Again, let me just review what we just did. We were at the original function. So the original function, I know when x is 1, the value of the function is 3, and therefore the inverse of f when x is 3, the inverse value of that function when x is 3 is 1. And now I need to go look and say, hey, what's the value of the derivative of the function when x is 1? And I see over here that that's going to be 2. And so I just found the derivative of the inverse, and that's equal to 1/2. Okay, let's try this last one. All right, so now I'm trying to find the derivative of the inverse of g at -2. Okay, so let me erase what I have up here, because we'll start from the beginning. I'll try to set up the same way. Let me actually erase this. You can go back and look at that if you need to. Okay, so first of all, let's, from our definition up above in this part, I know that this is going to be equal to 1 all over the derivative of g times inverse g of -2. Okay, that's really the main takeaway. Derivative of the inverse equals 1 all over derivative of the original function of the inverse at that value of x. Okay, so what's this equal to? So again, I'm trying to find -2. So I know g of -2 is equal to 2. Okay, but that doesn't help me. I'm looking for the inverse g of -2. So hey, I just switched the x and the y. So therefore, inverse g of 2, oh, I did it backwards. Hold on. I tricked myself there. Here's what I'm looking for. G of 1 equals -2. Therefore, inverse g of -2 equals +1. So we don't want that one. So this is now going to be 1 all over g prime of 1, okay, because inverse g of -2 is equal to 1, because when g of 1 equals -2, and now I come over here and say, hey, when x is 1, what's the derivative of g? That's going to just be 1 over 1, which is 1, okay? And that's what we're looking for. All right, that'll be part 2.